number is 456 that has realized by the London Justin. So actually, flight delays are major challenges in the aviation industry. It causes the operation disruption, financial losses, and the passenger dissatisfaction. So as the number of flights continues to increase every year, so the airlines need an effective way to predict the delay before the delay happening. So this study is into using applying the data mining and machine learning techniques to predict whether the flight will be delayed or rather on time. So actually, an accurate prediction of flight delays can help the airlines to improve their scheduling, resources allocation, operational planning, and ultimately is to improve the customer satisfaction. So there are actually three problems that multiple mentions. The first one is flight delays are usually affected by the multiple interconnected factors because flight delay is a chain reaction. When a flight is delayed, it will affect the following flights. So this is the interconnected factor in chain reaction. So the second one is the aviation data set is extremely large usually and often can contain a class imbalance issue. This class imbalance issue is due to the number of on-time flights will always greater than the number of delayed flights. So this imbalance will causing the model to bias that more toward to the majority class. So the third one is although the previous study has already making some algorithm on this flight delay predictions, but the performance is very depending on the data set itself. So it is necessary to apply different algorithm and evaluation methods for the evaluation data set. So for my research, there are three objectives. The first one is to identify and analyze the operational, scheduling, work-related, and error factors that are associated with the flight delays by using descriptive analysis and dashboard visualization. The second one is to develop a flight delay prediction model by applying decision tree, heuristic regression, and random forest algorithms. The third one is to evaluate to compare the performance of each algorithm used by using accuracy, precision, F1 score, report, and area under the RC curve in C. So in order to determine the most powerful and most effective algorithm. So for my study is actually provide a data-driven approach for predict the flight delays by using the machine learning techniques. And the developed models will support the airlines with better resources allocation, flight scheduling, and operational planning. And in terms to reduce their operational disruption, financial losses, and the important thing is for the customer dissatisfaction. We have to improve this. So now we move to the chapter 2, the future review. I'm actually taking some of the researcher papers that will help in methodology later. So from here, I can notice that the previous researcher found that random forest also demonstrate a superior performance for the flight delays compared to the other machine learning algorithms. Secondly, is previous researchers has already suggested that handling class imbalance issue before I develop this model. Because, as I mentioned earlier, this class imbalance issue, if I didn't solve it, it will affect my models to more toward to majority class. And thirdly, also have researchers found that the traffic density is one of the major factors that contribute to the flight delays. Yeah. So I think this is more useful for my methodology use later. So chapter 3 methodology. As you can see, I have two parts here, which is descriptive analysis and the research framework. But now we focus on research framework because I'm using this sub-element in the descriptive analysis. So this study is actually carried out by according to the knowledge discovery of database, which is known as KDB process, and I'm implemented by using the Python. So there are 5 stages in the KDB process, like data collection, data preprocessing, data transformation, data mining, and model evaluation. So the first stage, data collection, I'm actually using the secondary type of data and I'm obtaining from the tables. But I obtained 5 years of historical flight data, which is 2018, 19, 20, 21, and 22. I'm only using the 2022 data set because it has the smallest file size. It will allowing a faster processing time than the other 4 years data sets, and also it provided a sufficient data set for me to do predictions because this 2022 data set already contains approximately like 4 million of flight reports and around like 61 attributes. So after I decided the data set I use, I moved to the data preprocessing part. In data preprocessing, I'm taking several steps. The first step is I remove the missing values, I remove the missing variable. After that, I remove the cancel flight and directed flight. because these two attributes will causing the data leakage from my model and cause the model to cheat. After I remove all the missing value and the cancel flight and negative flights, I'm performing the class balancing by using random sampling. I'm taking 35,000 of delay flight and 35,000 of on-time flight together, and I provide them into a new file, shuffle again, and name this as new balance 50K dataset. So I'm using that balance dataset for my discrete analysis. So after I balance the class, how we determine the delay and the on-time flight by referring to my target variable, which is arrival delivery 50. This error stands for arrival, DL's delay 15 is 50 minutes. So this is decided based on when the flight is arrival 50 minutes late, then the flight is categorized as delayed. Yeah, delay is 1, 0 is on time. So after that, I pick up like 16 figures from my data training data. After I processing, I move on to the data transformation. Because they are existing of categorizing data in my datasets, which is origin and destination. The content of airport name is short form, like big name is PHP, product is KDS like that, so the airport name. I have to transform them into the numerical values by using the one-hot encoding. After encoding, my dataset is increased from 16 attributes to like almost 190 figures. This is because the name for each airport needs to become a separate figure. After that, I apply the figure scaling on the logistic regression because I want to improve the convergence during the data training on logistic regression itself. Because my data set have a different scale, data scale, so I have to make the figure scaling to avoid that the variable that have a larger value affected my model performance. So after that, I'm using three algorithms as I said earlier. Logistic regression, usually and random forest to train my models. And I use two regression methods, which is the first one, cross validation with number of 2, 3 lines, and cross validation with ratio, and trend test ratio, 90, 60, 40, 70, 30, 80, 20, and 90, 10 ratios. Yeah. So after that, I evaluate and compare the model's performance by using 5 matrices, which is accuracy, precision, F1 score, recall, and area under RC curve AAC. So the comparison is made between the two evaluation methods, cross validation and trend test. So now we go to the discussion analysis. I'm using the dataset balance dataset that I mentioned just now to make a discrete analysis. I want to see the airline delay factor. So the first from the operational factors, I can notice that the major hub airports always have a higher delay rate because of the traffic density that I mentioned in the visual review. So the second one is temporal factors. I can notice that during Monday, June, and July, the flight days occurrence is higher. And especially on the weekend range like Friday, Saturday, Sunday, weekend range, the flight days are happening the most. For a schedule factor that evening flights are usually delayed and the late departure environment show a high occurrence is delayed because it is a peak hours of the hours of the day. And also, I can notice the short and medium route distance are delayed more frequently. So after checking methodology, I have entered my data or according to my framework, then I get the result. I get the result separately. This is just a simple output from post validation. We can show becoming so here. Because it is logistic regression, we usually 3 random forest, number of 4, 2, 2, 3, 3, 3, type 5, 5, type accuracy, precision, recall, F1 score, and AEC. So this is just a sample output for the post validation, and I also have a sample output for trend test by application. So this data is actually showing the best performance from the class validation and the trend test display. Both of the model has the same model, most of the evaluation methods have the same model that achieve the best overall performance, which is random forest. Random forest is achieve the best performance and tenfold in cross validation and 90 and 10 ratios in trend test split. So although the first it just increased like almost like from 1 or 2% per year, but it shows that trend and test can perform well in my flight duration model, flight delay duration models. So, to make a conclusion, this study is successfully developed of flight delay duration models by using 3 algorithms: distribution, loss, regression, and random forest. So the discrete analysis also identified that the temporals, scattering, distributional, the first factor factors, and then achieve the stronger performance under the both factors. So this finding is indicated that the running planning can effectively predict the flight delays and support the decision making for the airlines in the aviation industry. So actually there are some for my research it has some contributions. So for the first one is successfully develop flight delay predictions by using a 50K of balance flight reports from a very large scale of data, which is 4 million, and transformed in a 50K of various data set by using random sampling of data. I successful using the two aggregation method with 3 machine learning algorithms, and I successfully identified the random forest as the most effective algorithm used for these models, and I successfully provided insight into factors that influencing the flight delays. So there are actually some limitations for my projects. So the first of all is the dataset did not include the weathers, airport congestion, and any real-time data. So this is the cost that my accuracy is only about 63% because I didn't include much of the data that I have. So the second one is the model. So the model is still achieved for the moderate radiation performance like almost 64%. Then the future, for what I think is the future research will incorporate the weather, traffic condition, and the real-time flight operation data when they carry out these flight delay predictions. So I think that's my presentation.
Thank you very much, Khai, for your very impressive presentation. Okay, I think the title is much good. Alright, so just a suggestion for you guys. Actually, in objective equation, it works actually. So for example, here you have the value that you compare. So the value is actually same to compare. So normally you just take any of it. If you want to put it as well, then you make it as another objective. Okay. Then my suggestion to you is once you have compared, you choose the best. What next? So what I do? I'm using that the best model to train my data for the future. Okay, so meaning that you will be using the random forest to predict the future, right? So that is called deployment or model deployment. So you can make it here as a fifth objective to deploy your model, blah 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 blah. Okay, understand? Okay, so my question to you is, if you look at the literature review here, okay, so someone had done the research using the random forest, and then it has clearly demonstrated superior performance. So six people have done it. So what actually motivates you to do the same things again?
Because I want to see that if my data set is fulfilled with the previous research. Because I think that as I mentioned earlier, the performance is very dependent on the data set itself. So I want to introduce performance in my data set to see the research review is it the truth for my data set also.
Okay, so from here I can see that your final result is 0.6 something like that. So do you satisfied with the result? Do you think that it is underfit?
I think it is just reach a moderate level because I don't contain as much information as I need. Actually, I don't have the departure time, arrival time, so like that. I don't have enough information, and so I think this is a limitation for me. So now in the limitation part.
Okay. So what is your opinion to boost the values of accuracy?
I think if the computation power is allowed, I will take in a more larger size of the data sets to train against, because actually this 50K data set and 890 of feature is quite heavy for my computational power and the computational time. So I think I will enter more data to train, and I will try to using another algorithms for like that to train the data and see whether the result is giving me the same in here or another view.
Okay, so you mentioned here that the future work is usually including weather, airport congestion, and real-time operation data, right? Yeah. So do you think that by including that, okay, so the result of the accuracy rate will be increased?
I think the answer is yes. Because if I have this additional information, I can know that this day is due by the weather, this day is due by the condition, and like that. I can know the delay reasons, and this will improve my accuracy and that basically that one. Okay.